Welcome to the NYSERDA Commercial Lighting Business Partners Program Site Lighting Webinar. We'd like to thank the Lighting Research Center for helping prepare this webinar. I am your presenter today, and I'm Ken Littell of ICF International, managing the Commercial Lighting Business Partners Program for NYSERDA. I've worked at ICF on this program for over 10 years and was actually an ally in the program prior to joining ICF. I've been in the lighting industry for over 30 years, and I hold my lighting certification, or LC as it's known, from the National Council on Quality for Lighting Professions, NCQLP. Again, welcome to today's presentation. So today we're going to cover the goals of outdoor lighting, talk about elements of good outdoor lighting, discuss how you can recognize and handle and mitigate light pollution and trespass, talk about what common light sources, luminaires, and controls are available for you to use, and discuss examples of simple, cost-effective site lighting designs. So there's several reasons that we light at night, and they include good outdoor lighting, which allows people to see others coming towards them and have time to assess potential danger. So good outdoor lighting may also deter criminal activity because criminals are much less likely to operate in areas where they feel they can clearly be seen and identified. Additionally, safety is improved by good visibility. If people can see well, they're a lot less likely to trip and fall over hazards. Drivers are a lot more likely to see pedestrians clearly. If people feel safe in the well-lit areas, they're much more likely to travel to them and spend time in them. So good lighting can also draw attention of people who might be walking or driving by the site. Good lighting also tends to make a site feel warm and inviting at night, and it can accentuate the features of site such as buildings and should blend in with the architectural and natural characteristics. And this all needs to be done while we're using the lowest possible energy amount. That means you want to use efficient lighting sources and luminaires, providing appropriate light levels and not wasting light by lighting areas that do not need it. So what are some of the elements of good lighting? Well, in order to develop a good lighting installation, a designer must consider the following factors. The first one is illuminance, which is just simply the amount of light. Then there's the Illuminance Uniformity, which is the distribution of light, and we're going to go into the details of these factors in the following slides. Then there's luminance, as opposed to illuminance, and luminance is the reflected light from a surface to our eyes, so when we see an object, we're actually seeing the luminance of that object. We're going to discuss glare, which is excessive brightness from luminaires. We're going to talk about aesthetics and appearance of the design and the luminaires both during the day and the night. And then we're going to talk about cost, both initial cost of installation and operating costs of the system over time. They're both issues when it comes to cost. Energy use, we need to discuss how much energy is used by a particular installation and what is a good way to design for that. Light pollution has a few factors, and generally talks about unwanted light up into the sky and also light trespass onto beyond the property lines of a particular site or space. When we talk about color, we're going to talk about two different types of color, correlated color temperature, or two different ratings for color, and correlated color temperature, which talks about the warmth or coolness of a particular color source, and then color rendering, which discusses the color rendering abilities of the particular light source that you're going to use, and that's measured as color rendering index, and we'll get into the details of these as we move forward. So each of these factors will be addressed more fully in the following slides. So this is just simply a picture that kind of brings it all together and it illustrates how all the elements have to integrate into good outdoor lighting. And you can see that there's points of interest near the awning. I'm going to start there. That's kind of a focal point for the facility as somebody's entering the space. That also becomes a transition space. You need to make sure that there's the appropriate amount of light there at that awning so that people are transitioning from the brighter space on the interior to the darker space in the parking area and vice versa. We also have to consider things here about direct glare. We'll look at some luminaires later and discuss how you can avoid direct glare. You want to be concerned with light pollution. You can see the person standing up in the window at the top of the building. That might be a bedroom, and that might be disturbing to them to have the light coming in the windows. So these are all things that we need to consider, and we're going to discuss during this presentation. And as I started to mention earlier, illuminance is just simply the amount of light hitting a surface, and it's most commonly referred to as light level. It's probably the most used and most often misunderstood and misused measure when specifying outdoor lighting. And we often simply refer to it as light level, and we need to consider exactly how we design to that. It's interesting that back in 1900, moonlight was actually considered the gold standard. If you had street lighting on particular streets, very often, if there was a full moon, the street lighting was turned off to allow us to take advantage of the full moonlight rather than using energy. I don't see us doing that very often anymore. A full moon also provides between 1/100th and 5/100ths of a foot candle, which is enough light for basic needs. You can actually see to be able to find your car, be able to function throughout the parking lot, and if you have a very clear moonlit night, you can actually read newsprint under that once your eyes have adjusted. So you really don't need all that much light to do the basic outdoor tasks. But when we talk about foot candles, what are we talking about? Well, in the United States, illuminance is specified as foot candles, and it's abbreviated as FC. 1 foot candle equals 1 lumen per square foot of surface area. Everybody else in the rest of the world measures it in lux, and lux is equal to 1 lumen per meter squared. 1 foot candle is roughly equal to 10 lux. If you're looking to be more specific than that, the ratio is 1 foot candle equals 10.76 lux. And moonlight actually gives us a very uniform illuminance. There's both uniform horizontal and vertical illuminance. This makes it actually an ideal situation for us to be able to see under various different outdoor applications. So we want to consider trying to emulate moonlight as we're doing a lighting design. So outdoor illuminance recommendations are actually set based on research that's been done about outdoor lighting needs of the general population to complete nighttime tasks. I think most of us are familiar with the Illuminating Engineering Society, and they publish various different recommended practices known as RPs for various different types of spaces. In this case, IES RP 20, which was published way back in 1998, is for parking lot lights and has some nice minimum settings to work with. Even though they really haven't been republishing it recently, it's still a good benchmark to follow. So that if you're looking at mean horizontal luminances, basically on the ground or on the surface of vehicles or whatever you might be looking at, they generally measure for parking lots, you're going to measure it at the ground. The basic light levels for basic conditions would be 0.2 foot candles, or if you're measuring in lux, it would be 2 lux roughly. If you're looking at more enhanced security areas where you feel like you need a bit of a higher light level, then it would be a 1/2 a foot candle or 5 lux. Minimum luminance, illuminance on vertical surfaces for basic conditions would be 0.1 foot candles, 1/10 of a foot candle, or 1 lux. And if you have an enhanced security area, it'd be 1/4 of a foot candle or 2.5 lux. There may be reasons why you would need to light at higher light levels, and we're going to consider some of those options. When you look at Illuminance Research, there was research conducted by Peter Boyce at the Lighting Research Center, and it actually showed that 1 foot candle average, or 10 lux average, on the horizontal luminance on the ground was enough light for most people to see objects clearly, to be able to identify spaces, detect people and objects at a distance, recognize faces, and provide a sense of safety and security even at areas that were identified as unsafe during the day. And what this diagram actually demonstrates is that when they conducted the research in New York City and Albany, people were asked if they felt safe in a particular area at these light levels. Once the light level at the site reached 10 foot candles, nearly everyone felt very strongly that the light level was safe. They felt safe. So that they found that if you could see all these points across the graph on the left-hand side where it says slightly disagree, slightly agree, the majority of the people actually fell within that 3-foot candle or 30 lux area, and it actually worked out very well. In a 1-foot candle area was the average illuminance for most applications, and then urban areas with more nighttime activity or maybe some commercial spaces where they might be selling product vehicles at night, then they wanted to have up to 3-foot candles for a desired light level. Light levels higher than 3-foot candles generally aren't necessary unless you have a very specific purpose for that. As we discussed a few minutes ago, we want to try and emulate moonlight, and part of doing that is to create Illuminance uniformity. How even is the light? So this is the distribution of light over an area, and it's in many ways as important or more important than the average light level itself. Research has shown that we need very little light to see well at night. However, if the light is not uniform over the entire site, it makes it more difficult and less safe for visitors to attend that space. So a luminance uniformity is simply a measure of how even the light is across the site. Again, based on research and published in the RP20, luminance uniformity of less than 10:1 is recommended for most outdoor types. What does that mean, 10:1 uniformity? Is that the highest light level and the lowest light levels should not be separated any more than by a factor of 10. It's very important for safety and security because it allows people on the site to see the areas around them. I know that recently the Lighting Research Center conducted one of their outdoor lighting events, and they take people to an area where it uses high-pressure sodium, and there's a lot of shrubbery and trees around the area, and the light levels really drop off on the perimeters. And it was observed by many of the people there that when you get into those kind of situations, you really don't feel as safe. So you need to consider uniformity and also perimeter lighting when you're talking about the space. When you're doing your lighting design, you want to make sure that you're overlapping the light distributions to avoid pools of darkness between the lighted areas. You want to try and avoid making it too bright underneath the fixture. You don't want to have a lumen dump right below the fixtures, and then you have dark spaces in between the fixtures. These are all things that you need to consider when you're doing the lighting design. Luminance, as opposed to illuminance, is the amount of light that's reflected back from various different items. So in the case of luminance on surfaces, darker surfaces such as asphalt need actually more light to appear as bright as lighter surfaces which reflect more light than the darker surfaces. And then they reflect them back to your eye. This is not only true for roadways, but it's also true for building facades. So if you have a building that is made of darker materials, you may need more light to produce the same brightness appearance to the surrounding public. You also have to consider the luminance of luminaires. Luminaires with high luminance may cause direct glare and visually be uncomfortable at night. We're actually going to look at that in a second here. So when you're considering glare, what it really is the excessive brightness against dark background. At night, when everything else is dark, including the sky, a bright luminaire can actually be very uncomfortable to look at. Glare can potentially reduce visibility, especially at a distance. If the luminance of a luminaire is much higher than the surrounding area, a person may be unable to see beyond that point. So some methods for reducing glare are to avoid luminaires where the lamps actually drop below the housing of the fixture, that they can be seen from the normal viewing angles. You also want to consider using full cutoff, or semi-cutoff luminaires, which reduce light, high output, and high offending angles. Now, you're going to notice when we discuss this a little bit later that full cutoff, cutoff, and semi-cutoff luminaires, those actual designations, are being replaced by other luminaire classification systems. So we'll discuss what those details are in a few moments. One of the other things that you really want to consider when you're doing good lighting is the aesthetics of the space. Consider how they look both during the day and the night. If you have a very contemporary site, you want to make sure you're using contemporary fixtures. If you have a traditional site, you want to use traditional fixtures, and we'll look at some different types of fixtures in a few moments. You also want to make sure that you coordinate the types of fixtures and the architecture throughout the entire space. So if you're using post lights, wall-mounted lights, and bollards all on the same space, you want to make sure they coordinate with similar styles, whether that be traditional or contemporary. You also want to consider using similar sources as far as correlated color temperature and as far as CRI, so that there isn't a major difference between the various different sources when they're lit at night. Everything should really blend in with the surroundings as much as possible. When you're considering doing your lighting design, you want to really dig into cost and energy. And when you're talking about cost, there's 4 primary parameters to consider: equipment cost, installation cost, operation cost, and maintenance cost. If you decide to design with the least expensive, least costly equipment, you may find that this is more expensive to maintain and more expensive to operate due to higher energy consumption. So you have to seriously consider the equipment cost. Energy and maintenance costs are also very important when you're talking about outdoor lighting applications. So energy is typically the highest cost over time, and maintenance with exterior applications can be challenging because you're talking about light poles that are higher than normally accessible by a typical stepladder. You might need some kind of a lift to get in and change the light bulbs, so you want to consider all of these when you're thinking about your lighting design. When you're looking at energy, there's 2 primary components: power. And when you're thinking about power for a particular site, you want to consider the lighting power allowances as set forth by the energy codes, whether that's a state code or local code. And then you want to also consider time. How often do these lights operate? Do they need to be on all night long from dusk to dawn? Or can we turn some of them off during that period? Can we attach some motion sensors to them? Not all technologies lend themselves well to motion sensors, but it's actually a consideration. Or can you dim these particular fixtures that you're using for off-site or off-time hours? Another element of good lighting is color. You want to make sure you choose your colors wisely. And you've got 2 versions of color that you need to consider when you're talking about a light source: correlated color temperature. And research shows that light sources that have higher CCTs, which would be measured in Kelvin, 4,000 Kelvin and above is a higher CCT, it's generally going to appear brighter at night due to the cooler appearance of the light that they emit. You may be able to use this to your advantage when you're designing in an outdoor lighting application, and we're going to discuss that as far as various different SP ratios and what that is and how you want to think about that when you're doing your design. Color rendering index of the light source should also be appropriate for the particular site. Most outdoor lighting applications allow you to use a 60 CRI or higher. If you compare that to interior, typically you're going to use an 80 CRI or higher in an interior space. So you don't have to be quite as concerned with color rendering in exterior spaces, but it's still an issue to consider. As we mentioned, correlated color temperature may have an effect on the ability of the eye to see in particular spaces. So most outdoor light levels lie within a range of something called mesopic vision. And under mesopic light levels, both photoreceptor types, which are rods and cones, are operating for vision. When the mesopic region lies between scotopic, which is a starlight condition, when only the rods are operating, and photopic, which is indoor lighting type conditions, when only the cones are operating. And this mesopic area is when both of those are functioning at the same time. The eye is much more sensitive in these applications to shorter wavelength at low light levels. So your cooler sources are actually going to do a better job for visibility in those applications. Since sources have different spectral power distributions, their visual effectiveness will be dependent upon the light level. So what does the SP ratio do? Well, we could actually do a presentation just on SP ratio and really get into the mathematics about it. But what the basic terminology behind the SP ratio is: a ratio of scotopic to photopic sensitivity and it may provide some advantage to light sources with shorter wavelengths. So even though we like to be as technology neutral as possible, you may be able to use a metal halide or a fluorescent or an LED type of source with cooler color temperatures, shorter wavelengths, and this will actually allow for you to use lower light levels in those spaces and in turn use less energy. So you want to make sure that you're providing the energy savings when the spectrum of the lamp is matched to the visual needs of the site and the people using the space. So some other things to consider when you're looking at good lighting is light pollution and trespass, and we have a few slides to discuss that go over things like what is light pollution, what is light trespass, and why are they important, and how we need to handle them. So light pollution and trespass, really two components. Light pollution, also known as sky glow, is light that's up into the sky. You should know that this can actually happen one of two ways. Is that either this can be emitted directly from the luminaire, if it has high angle brightness or high angle distribution, but a lot of times, especially in the Northeast, it's light reflected off the ground. Here in the Northeast, where many months of the year we have snow on the ground, if you have a lot of bright downlight pole lights out in the parking lot, that can actually create a sky glow situation. Take a look at a city when it's a very snowy day at night and see how much light you actually can see reflected back in the sky. So what you can do is you can mitigate this by selecting luminaires that control the light, and we're going to discuss specifics on that in a few minutes. And they can also use darker colored pavement. So here's where we run into issues that run counter to what we were talking about the amount of light that you need reflected back from a surface. So you want to use darker pavements if you're trying to reduce light pollution. Now, light trespass is actually when the light extends beyond the property space. So a lot of townships, municipalities actually have light trespass ordinances that say that your particular property cannot have a certain level of light extend beyond your property by a certain distance. So you need to be aware of what these are before you do your lighting design for a particular space, or a particular area. You want to consider things like installing house-side shields, using trees or fencing to actually help block the lighting, or moving the poles farther away from the boundaries to reduce this light trespass. So how do we actually categorize all of this? Well, the Illuminating Engineering Society has defined different zones where lighting should be designed to coordinate with local conditions. So if you're talking about very rural conditions, you can look at LZ0 and LZ1, which are lighting zone 0 and lighting zone 1. And they're extremely sensitive to light at night, and light can actually be disruptive to wildlife, to individuals. These are areas where you typically don't want any light, or as minimal as possible. LZ2 is your typical rural area, and where lighting should be designed to levels that are not high enough to support, that are high enough to support vision, but just not high enough to be offensive to other occupants. Typically, 0.2 or a quarter of a foot candle or less is really a good place to work with for LZ2. LZ3 really falls into the suburban area. People may be sensitive to the amount of light that's out there. So you want to consider a 1 foot candle light level. As we discussed earlier, 1 foot candle is actually a very good way to see an exterior lighting at night. And then LZ4 is considered higher activity areas such as city or commercial areas. If you have a nighttime and a 24-hour gas station, if you have an automobile sales location, these are places where you might consider higher light levels. But 3 foot candles covers most of those applications. And one last thing that you want to consider in these various different areas is can you turn off some of the lighting at night? There are other areas where you are required by code to not turn off light levels, but if you have that ability and if it's within code, you want to consider turning off the lights at night if possible. So how do you weed through all of this and figure out what's the right way to go as far as light pollution, what the right light levels are, what's too much light pollution, and how to avoid that? Well, the Illuminating Engineering Society and the International Dark Sky Association have developed a model lighting ordinance which is actually written in code language so that you can use it as adopting for municipalities for their local ordinances. And this is for people who might want to limit pollution, light trespass, and glare. So the model lighting ordinance addresses the need for strong and consistent outdoor lighting regulation. It actually addresses sky glow, which we've already discussed, and light trespass and glare by limiting the amount of light per zone and putting a limit on the total luminaires allowed per area. This also feeds into various different energy codes, so sometimes they actually coordinate and correspond with each other. And there's two paths to compliance. If you remember a few minutes ago I mentioned full cutoff, semi-cutoff, and cutoff luminaires. Well, we've actually started to transform to a new rating system called the bug rating system, which basically rates backlight, uplight, and glare. And this is one method for rating or eliminating sky glow and luminaire pollution or light pollution. Another method is using the performance method, which actually quantifies the amount of light leaving the entire site. And there's calculation methods for that within the model lighting ordinance. You can actually download the model lighting ordinance for free if you go to the Illuminating Engineering Society website. So we've been discussing bug lighting, bug qualifications and scores, and how does that all come together? So to accompany the model lighting ordinance, the Illuminating Engineering Society, in its most recent lighting handbook, has a new classification system, Luminaire classification system, LCS, for outdoor luminaires. This replaces the old IES intensity distribution that we've been discussing, the full cutoff, cutoff, semi-cutoff, and non-cutoff. And it really breaks down three angular zones within the luminaire classification system for forward or useful light, for backlight, and uplight. And this covers the region above 90 degrees for the uplight and contributes to light pollution. The LCS is actually an important step in an evolution toward outdoor lighting design because it clarifies luminaire photometric performance by grouping emitted lumens into different zones by vertical angle, which can be related to light trespass, sky glow, and high angle brightness control. Now, at this point, most pole-mounted outdoor luminaires actually have bug ratings addressed to them or attached to them, and you can check this on their specification sheets or check back with your luminaire manufacturer. The luminaire classification system breaks this down into 10 total zones and various different degree angle separations. There's forward light, 4 zones in the forward light area, there's 4 zones in the backlight area, and there's 2 zones in the uplight area. And the uplight area is from 90 degrees and above, and everything else is below 90 degrees. And this allows, by looking at the bug scores, to get a very clear picture of where the light is coming from a particular luminaire before you actually choose it in your design. As we mentioned, there's some types of buildings that you want to consider your aesthetics with, and there's a lot of different ranges of different types of luminaires available. There's luminaires that are available with different types of styles, such as traditional, contemporary. You have different installation applications. You can have pole-mounted luminaires, which is typically used for large areas of parking lots or roadways. If you need to get more ground level for pathways or walkways, you can use bollards, and this allows you to do the generally low-level illumination. Or you can use wall-mounted luminaires. Very often these are called wall packs. Or wall grazers, and you want to consider typically having things with cutoff on those, which shields forward so that it doesn't produce light way beyond the property line. Spotlight and floodlight luminaires are lighting elements for the business of the space, whether that's a building, whether that's architecture, whether that's entryways, exitways. Facade lighting also has luminaires that might be vertical mounted. And then landscaping lighting actually looks at the various different features around the landscape, such as shrubbery and trees. And they typically don't provide any general lighting. So we've talked about the luminaire classification system, which really takes a look at how the light is emitted out of the fixture, but then you also need to consider what the lighting patterns are. So you need to look at luminaire light distributions which we look at in 2 steps: lateral light distributions and vertical light distributions. So a lateral light distribution, they range anywhere from type 1 to type 5. Most often you see type 1, type 2, and type 3 are very often used in roadway. You can see like type 1 and type 2 may be on the center of the roadway or at the edge for type 2 and type 3. Type 3 can also be used within parking lots, but that's generally used at the perimeter for type 3. Similarly with type 4, which is most commonly known as forward throw. And then you have type 5, which is available in various different types of distribution, whether it's a square or a round, but this is a perfectly symmetrical distribution. It's got the same amount of light coming out in all different angles. So you want to consider those light distributions when you're trying to provide proper coverage and uniform lighting on your space. Then secondarily, you want to look at vertical light distributions. You want to consider how far forward that light is being thrown from that luminaire, again, to consider the coverage. Is it a short or a medium or a long distribution? So these are all things that come into play when you're considering your distribution. They also have an effect on what your pole height and your spacing is going to be. Based on what kind of lighting pattern distribution you're looking at, you might have to have the poles spaced more closely together or higher to provide the uniform distribution. So you need to consider all these options when you're considering your lighting distribution patterns. So let's take a couple of minutes and talk about light sources, luminaires, and the types of controls that we can use to control them. We also want to look at rated light. So here's some common sources that I think most of us would be familiar with. High pressure sodium tends to be a little bit yellow or orange. It's what we call a high intensity discharge source, and it has an arc tube, and it does contain sodium and mercury, so everybody's using that bad word, mercury. But the downside is that high pressure sodium are still one of the most efficacious sources out there, and we'll show you the actual light outputs in a minute. But unfortunately, their spectrum, as I said, yellowy or orange, or some people actually call it pink, actually has very poor CRI, and they're not very easy to dim. If you do decide to dim high pressure sodium devices, you can only get down to about 50% of the light output. And then with HID sources, if the light goes out, if there's a power outage, then it takes time for the sources to cool down and warm back up before they can restrike. Metal halide, which is similar in high pressure sodium in that it's a high intensity discharge source, also has an arc tube, also has mercury, is another source, except it tends to be a much whiter source, so it has a range of CCTs, correlated color temperatures, available, and it generally has fairly good color rendering index for exterior types of spaces. But again, like HPS with the high intensity discharge source, it has a restrike period that you have to be concerned with. Fluorescent. People comment to me all the time that fluorescent isn't necessarily something we see very common for exterior lighting for parking lots in the Northeast, generally because it has a hard time with cold temperatures. That said, I have seen a few parking lots over the years, were probably built back in the 60s, that use these great big helicopter-looking poles with these fluorescent fixtures on it to actually light the fixtures, or light the cars that were in the space. So it's been done, but it's not necessarily the easiest source to use for wide area lighting. You could consider it, though, for closer areas, for accent lighting, landscape lighting, facade lighting, that kind of thing. Generally, you've got a wide range of color temperatures available and good color rendering available for it also. Induction lighting is also known as electrodeless fluorescent lamp, is actually powered by a radio frequency transmitter. And like other fluorescent sources, it does also contain mercury and rare earth phosphors. Now, while some manufacturers have published longer rated life than high pressure sodium and metal halide, there's currently no industry standard that tests for a testing procedure for induction lamps. So the cautionary tale is, if you see an extremely long life on induction lighting, this is not tested necessarily under the same methods or under a standardized method when you're comparing source to source. LEDs are becoming more and more popular. They're solid-state sources. They don't have mercury. They do have high efficacies. We'll look at the numbers in a minute. Correlated color temperatures, they've got a pretty wide range of those available. And color rendering index, again, for exterior applications is really good. LEDs also can be dimmed fairly easily, and they don't have as much limitations as some of the HID sources, which you can only dim down to about 50%. They typically, at this point, are still more costly than going to HID sources, but it's definitely something worth considering for exterior, because they've been done for quite a while now, LEDs have, for site lighting. So let's look at some of the common site source efficacies. Now, when you're looking at this table, understand that this is just the light source only. This does not take into consideration the ballast losses. It does not take into consideration the fixture efficiencies. So these lumen outputs, or lumens per watt, can actually be derated by anywhere from 20 to 30% when you're looking at these. As we mentioned a minute ago, high-pressure sodium, even though the color isn't all that great, tends to have the best lumen output per watt out of all the different sources. But LEDs are catching up very quickly, and we probably need to update this slide and get it show some of the more recent applications of LED as far as the light output. Metal halide is right behind LED as far as light output goes, and is usually a pretty good source to work with as well. Then we want to look at lamp life. While high-pressure sodium really was ahead of the game as far as lumens per watt, they're pretty much about average as far as the middle of the pack goes, as far as the lamp life used in street lighting. And metal halide is not quite as good as high-pressure sodium. You can see light-emitting diode tends to stretch a little bit beyond that and is improving regularly, getting out to 50,000 hours and some beyond that. And induction is regularly reported as being 60,000 to 100,000 hours. Again, be careful of the manufacturers, the sources that you're using with induction, because there aren't any standardized testing methods for using induction or electrodeless lighting. So how do you control all of this? Well, probably one of the most common sources that everybody's used to seeing are photosensors. Here's the old Cobra heads. There's still a lot of them around. You can just pop the photosensor onto the top of the Cobra head with a twist and lock. It gives you the on-off switching response. If it fails, it generally is going to fail to off, so the lights aren't coming on all night long every single night. There's one thing you have to be really careful of with photosensors. If you can see in the picture in the upper right-hand corner of the photosensor, there's a lens on the front end of the picture, and that lens is where the outdoor light is actually taken into the photosensor. If that's pointed directly into the sunlight, like a southern exposure, that tends to burn those sensors up prematurely. But if they're positioned correctly, which is generally aiming north, then you can usually get about a 15-year period out of a photosensor. You can also tie photosensors into other controls, which we're going to discuss, such as time clocks, so that you can have it come on when it goes dark, used based on the photosensor, and then maybe at 11 o'clock or midnight have the lights go off, even though we still have dark hours throughout the rest of the night, using a time clock. So these are some of the other things that you consider. Photosensors can also be a trigger for dimming the luminaires so that you can have less light at night or turning off particular devices. Astronomical time clocks are an excellent way of controlling exterior lighting. It allows you to program it so that you've got scheduled control on and off. You can adjust it based on the longitude of where the space is actually located and the latitude, and you can use the standard clock setup so that it can have a preset schedule to go on and off at particular times. So if you're closed at 9 o'clock, but you still want your facility to have light till 10:30, 11 o'clock, you can set the time clock to go off to that time period. This can actually control up to about 32 different lighting zones, and it allows the building owner a lot of flexibility so that you can have different zones, different areas. Maybe you need to reduce the perimeter light at an earlier time than you do the rest of the light in space. And then there's one more thing I mentioned earlier, is you also need to check with local codes about shut-off times. There are some codes that are going to require that lights are shut off by a certain time, but conversely there's also codes that require that certain devices or certain fixtures are left on all the time. So you need to make sure you're aware of what they are. Motion sensors are just now getting into the exterior lighting over the last couple of years. We've been using them internally inside for quite a while, but they're just becoming more common in outdoor lighting. I think most of us at this point are used to seeing the motion sensor attached to the little decorative lantern next to somebody's doorway at home. Those work pretty well, or maybe the sensor attached to the 2 bullet lights on the front of the garage. This will also detect motion and turn the lights on. But now we're actually expanding beyond that, so we've seen these get into pole-mounted applications, turn-off lights, or reduced lights if you have it set up to a dimming control. Again, with HID, you can't turn them off completely, otherwise you have a restrike time. So you have to consider using dimming ballasts in those applications. Check again with your local codes. It may require lights on all night long for specific applications, or may require lights to be off by a certain time. So you want to make sure you consider all those applications when you're looking at what controls you're going to use. Okay. So now we've talked about how we put this all together. Let's look at some actual installation examples. So if you have an office park, you can see from this drawing that we had a large parking lot area using back-to-back cutoff luminaires in the parking lot on the poles. There was also low wattage building-mounted luminaires that were shielded so they didn't extend too far beyond that perimeter, the walkway perimeter. And then you also consider using white light sources. And then we can also dim the parking lot light levels so that after midnight there's still light out there, but it's not so oppressive that it's bothering people around the surrounding areas and creating a light pollution situation. You want to consider when you're doing this that you don't exceed that 10-to-1 ratio of uniformity. A campus green, a little bit different from an office park. You have a number of large buildings surrounding an open park-like area with a lot of white walkways. And so the moral of the story here is these are used both day and night. So you really need to consider the aesthetics of these particular fixtures as you're making your design. You also want to minimize light pollution and glare. So even though, as you can see in the lower right-hand corner, they show a picture of a rather traditional post-top luminaire and then a rather contemporary wall pack, that might not necessarily have been the best mix when you're talking about fairly traditional-looking buildings, but it does a good job as far as creating cutoff on the post-top and shielded wall luminaires so that it's not exceeding light trespass. And also you want to consider white light sources here for those particular applications. Local shopping center, kind of a variation on the themes we've been looking at. A little bit different scenario as far as the parking lot lighting. It includes covered walkway between the stores, and this is an all-night grocery store application, so there needs to be light there all night long, but what else can we think of to do this a little bit differently? The pole-mounted lighting is a type 5 distribution, so it's a symmetric distribution. You can see that from the way this drawing looks, that we've got fairly symmetric patterns coming from each one of those individual poles. It's very uniform, and it's providing uniform lighting of about 3-foot candles. And then the canopy lights underneath the long walkway are going to provide higher light levels near the building, allowing the transition in and out of the stores. So if you have to be 24-hour operation, and you need light 24 hours, what can you do is you can consider dimming down the light levels, let's say at or after midnight, so that it's a little bit more comfortable from a light pollution and surrounding area standpoint. Another application that we can look at is a group housing or a hospitality area. This is going to be lower-rise buildings adjacent to parking lots. The residents and the visitors may be coming and going at any hour of the night, and they're going to access it through the front of the building. So you need to have that perimeter walkway lighting as well as the parking lot lighting. There's actually a pendant-mounted fixture, in this case, underneath the canopy. The canopy itself is painted white, which continues to add brightness to that particular space and provides a better transition between the interior and the exterior spaces. And the post-top luminaires in this application are actually dimmed based on a time clock setting so that it's more comfortable at night considering the surrounding areas. Now the school applications, they generally have a fairly large parking lot adjacent to the school building itself, and very often these spaces are used after dark, and there's also the potential for vandalism on school grounds. So these are all things that have to be considered. So in this case, they use perimeter pole lighting, and lit into the center of the parking lot, but also had decorative period lanterns marking the front entrance. The front shielded wall packs also face away from the building and help to light the building facade. And then they use type 3 cutoff luminaires at the perimeter, so they're throwing light into the center of the space. So the wall packs here were actually providing about 3-foot candles into the space throughout the parking lot area, and then also, around the walkway area. And then the type 3 distribution luminaires were providing 2.5-foot candles within the parking lot space itself. So we've discussed a lot of details when you're talking about exterior site lighting. And so here's some summaries that you can work with. Is that you want to promote security and safety. You want to make it a comfortable space for occupants to use. You want to make sure that there's improved visibility. If you have improved visibility, it's a safer space. It's a more comfortable space. You want improved visibility for pedestrians and drivers. By having a nicely lit space, you're promoting consumer traffic. You're going to get people into those retail spaces, and they'll be able to actually come in and be comfortable and want to spend time in those spaces and spend their money. And then the approved aesthetics at both day and night. You want to make sure that the luminaires that you choose fit with the style of the building and the architecture. And then you want to also consider using the least amount of energy possible. Consider using your SP ratios. There's a number of different sources out there, including the Illuminating Engineering Society Handbook, that lets you look more carefully at SP ratios and how to use them. And so we'd like to thank you for your time. If you have any, we're going to take questions in a moment, but beyond today's webinar, if you have additional questions, you can contact one of the account managers across the state. We will be sending out these slides to everybody who attended today's presentation, so you'll be able to get these contact details. And then you can also go to our commercial lighting program webpage on the NYSERDA website and send us contact questions in the commercial lighting program email or through our toll-free number. And so with that, I'm going to take a look at the questions online and work to answer those. Okay. At this point, we don't have any questions online, so I'm going to open up the phone lines, unmute the phones.
Would you like your guests to be able to unmute their own lines by pressing *6? If yes, press 1. If no, press 2. All guests have been muted. You will now rejoin the meeting. All guests have been unmuted. You will now rejoin the meeting.
Okay, we have unmuted all the lines, so I'd like to open it up to any questions on the phone. Does anybody have a question about the presentation today? I couldn't understand that. Did somebody have a question on the phone? Okay. Well, again, we'd like to thank everybody for their participation in the presentation today. We will be sending out the presentation to all attendees, so you have a copy of the presentation, and you can fill out a quiz so that you can get a certificate for your participation in today's event. Stay tuned for other commercial lighting program presentations. Again, we thank you for your participation and have a good day.